Hi friends, this is the last time you'll watch me in a video. My vacation's almost over. If you're watching this on Monday morning, we're just having a pool day today, so that should be very nice, and like shopping and things. Tuesday will be our travel day back home. I won't be home till like really late in the night, so be nice to me on Wednesday morning because I'll be tired and probably cranky. So watch out. Okay, so today what we're going to do is we're going to look at homework 6.8. Your sub should hand that out to you. You're going to need your brown sheet and maybe your ideal gas law formula or flowchart. So today, just like all the other days, you'll have, I made my key for the homework, so while you're working on it, you can check your answers. Today's key is on this lovely red color, so don't burn your eyes with that. Okay, so let's start by taking a look at some of these problems on your homework to work through these examples. This should be a very simple review for you of Dalton's law of partial pressures and also ideal gas law, all the gas laws, nice big review. Okay, so I'm going to set up, I'm just going to review with you a couple of these problems and then get you set up with a couple of other ones, and then I'm just going to give you work time for the rest of the time period. If for some reason you did not finish any of those homeworks or you maybe had a couple of questions and you were still working on them, today's your last day to get those turned into the trace before they're marked late. So if they're just not in my tray when I get back to school on Wednesday morning, they're late. So make sure that you have any work that needs to be done, make sure you have it done. If you do have questions, we will have a work day on Thursday and Friday, or Wednesday and Thursday. You don't have school on Friday. So then I'll be sure to answer your questions and review any of the things that I taught you in the videos when I am here in person and can answer your questions. Okay, so let's take a look at your homework. Numbers 1 and 2 are very straightforward. You shouldn't have any problems with those. Let's take a look at that number 3 there. So number 3 says 22.4 liter container at 0 degrees Celsius contains a whole bunch of different stuff. What are the partial pressures of each of these gases? Okay, so let's start by writing our things down, and then we can figure out what we need to go from there. Okay, so I'm just going to write the numbers down and we'll fill in our variables later. I see that I have degrees Celsius, so I need to convert that to Kelvin straight away. You should be able to add 0 and 273 in your noggin. And then we've got all of this other information. So in order to know what to do with all of those mole amounts, let's start by filling in this side of the little table first, and then we'll move forward. Okay, so liters. What is the variable for the unit liters? Volume. What is the unit for degrees Celsius? Temperature. And then we're given all of those informations about all those moles. What is the variable for moles? Good. Okay, so already, without even needing to fill this in, I see that I've got a V, a T, and an N. If you have those three things, we can presume that we're going to also need a P and an R. Okay, so the question says, what is the pressure? So that's your question mark. Does it tell us a unit? Let's take a look. Sometimes it'll say, what is the pressure in ATM or millimeters mercury? This one doesn't, so you can choose whichever R value you feel most comfortable with. I prefer ATM, so that will be what determines which R value I choose. So that'll give me that one. If you prefer the millimeters mercury, then you'll use 62.36, and etc. So just whatever you want, doesn't matter. Okay, so this is our question mark. This is what we need to solve for. So we're going to have to put an actual number in for N. Now, because our question is a partial pressure one, what we actually are looking for is the pressure of all of the gases. So we need the partial pressure. I'm going to write this in a different. Oops. We need the pressure of, the first thing is N2, then we need oxygen, then we need helium, and the last thing is carbon dioxide. Okay, so we could calculate all of these pressures for each one of these gases by themselves using the ideal gas law. And then you'd do the ideal gas law 4 times. But there's an easier way we can use Dalton's law. So I'm going to write my formula for that down. I'm just going to start with the first gas on my list. So the pressure of N2 is equal to, now we can write, there are 2 different formulas for Dalton's law. There's pressure plus pressure equals total pressure. That's not the one we want though. We want the one that is just worried about nitrogen in this example. And so I need to find this friend. What is X? Do you remember what X stands for from last class? You should have written this down on your brown sheet. X stands for the mole fraction. So if we find the mole fraction and the total pressure of my entire system, we should be good to go. Okay, so if I want to know what the total pressure is for all of these gases, which N value should I use? Should I use the one for just nitrogen or the one for just oxygen? No, I have to find the N total for all of the things. So you can do that. These numbers aren't super hard to add. We'll have 0.3 plus 0.2 plus 0.4 plus 0.1. And what do you get when you add all those numbers up? Oh, that is one janky looking 0. My bad. You get, and I'm going to write it in a different color here. We'll use our orange friend. You get 1.00 ATM. Now, this is an aside on significant figures. We were just adding. We have all of these with 2 decimal places, 2 decimal places, 2 decimal places. That's how many decimal places are in the answer. So while we had 2 decimal places for all of these, this friend has 3 decimal places. So that is one of those tricky things because the rule is different. Okay, so find P total using your ideal gas law. Once you know what P total is, you can find the pressure for each one of the gases. Remember that the mole fraction is equal to the number of moles of that substance. So in this case, we have 0.3 moles of N2 divided by the total number of moles, which we already calculated as that one. Oh. See this? That's the wrong unit. I have an actual student. You guys, I have an actual student in the classroom right now. My mom is in here. Why didn't you say anything? How dare you let me keep going? Just kidding. It's fine. It's fine. It happens. We make mistakes. Oh,
part of the problem is because when you added all your things, you forgot to put your units with the.
I didn't. Yes, that's true. That's
0.30, 0.20. See, that would give me already minus points.
Okay. I have to shush her. So really, what Mom was saying was, if you don't put the moles here, that's how you know that you get a wrong unit there. Speaking of things, in my last video, I was like, oh, I gotta get going because I only have 2 more minutes to get down to Carter's solo. I totally made it. I walked in just as he was about to start, and Carter, you did such a great job. I'm so proud of you. I know that you were not happy with your performance. It happens, so don't feel bad. Beethoven's my favorite composer, and that is the song that I never learned because I always felt like it was too hard for me. So, well done, buddy. You did a good job. Okay, so let's see. Where are we at? This is your mole fraction, though. This is not the end of your problem. I've got a little more space here. So you're going to have to multiply this by whatever you calculate for P total. What should be your unit for when you solve for the pressure of each of your gases? Well, it depends. I chose atmospheres here, so that should be my unit. If you chose a different unit, then use that unit. How many significant figures should you have? Now you're going to have to think a little bit. How many did you get when you solved for your pressure? So if we look back at our table, 3, we gained significance here, so 3. We gained significance here, so another 3, we don't worry about him. So you should have 3 sig figs in this answer here. So when you're doing your problem with the mole fraction, you have 2, 3, and 3. So your answer for this actual, what you're trying to find, you should only have 2 significant figures here. This is tricky, and this is where you really just have to pay attention and make sure that you know what's going on in significant figure land. So I'm going to give you an answer for this. I expect you to have calculated what this is, but just to make sure that you're on the right track, you should get 0.30 ATM for this answer. So you're going to, no, is this all that you're looking for? Is this the end of the problem? No. You need to figure out what all of these pink friends are. So make sure that you do that again for this, this, and this. Yes, these are long problems, and yes, they are tedious. Welcome to chemistry. Okay, wonderful. I would like you to take a look now at number 4. You can finish that up after the sub turns off this video. I shouldn't be talking for as long today, so you'll have more time to work. In number 4, you actually have a pretty simple problem there, but you're going to have to be careful about reading. And I don't want to spoil your fun, so I'm not going to help you with that, except that I'm going to give you a little tiny tidbit here. You need to remember that the 840 torr is the total pressure. So just when you read that, that is the total pressure. That's not what you're going to use, though, to solve the problems. Like, you need that at the beginning, but you'll see. I don't want to spoil the fun. And then the 2 problems on the back side are both Dalton's law problems, but they also require a little bit of thinking. When you see the key, I actually had 2 more problems planned that I wanted to do for you, and then I decided, no, I've made you do enough work. So you have quite a bit more space on your actual paper than I had on mine. So when you're looking at the key, just look carefully about what it is that I did and how I got those problems, or how I got those answers for those problems. Be careful with your significant figures, and remember that there are different rules for adding. And because Dalton's law is an adding problem, you got to watch out for that. I think that's it. I don't think there's anything else I have to tell you. Our next classes, Wednesday, Thursday, will be review days. Could be a good chance for you to ask me questions. If there was anything in any of my videos that I wasn't clear about, I'll be happy to re-go over that. If you missed class and I was also gone, you can watch these videos at home. They're on Google Classroom. If you want to go back and re-watch them because you were not paying attention or because things were a little bit confusing to you, go back and re-watch them. They're there for you. Like and subscribe. Just kidding. Do not like and subscribe. And let me think what else. We're going to have a test on this pretty soon. So I just haven't thought through that all. We'll decide that when I get back. And I just want to see what your progress is before I decide when the test will be. But maybe next week. We'll see. Awesome sauce. I really appreciate you guys. Really be kind to your sub. I hope I had a nice vacation. And I hope you guys did okay without me. I apologize for being gone, but you know, as they say, c'est la vie. All right, you guys be good. Behave yourselves. Love you. Bye.